Yeah, and you know this, I've always taught graduate students that the easy part is designing and conducting the experiment. The hard part comes later, right?
Hello, meat folks. Welcome back to the MeatsPad podcast. It's your happy and hungry host, Phil Bass, back for yet another exciting week here in the world of meat enthusiasts. Today, I've finally reached my triple crown. I've interviewed a number of folks over the years who have been great influencers and advisors to me, and especially advisors to my graduate time. Dr. Bob Delmore and Dr. John Skanga. Dr. Delmore was my master's major professor, and Dr. John Skanga started me out on my path to my PhD. However, as life is wont to do, career changes occurred during that time, and I was passed off into the very capable hands of Dr. Keith Belk. And so here is my Belmont Stakes win right here. I got Dr. Belk on the line for everybody, and we're going to talk a little bit about a little more about the background of science. And so, first off, Dr. Belk, thanks for joining us today.
Yeah, sure.
And for those who aren't watching the video, I really encourage you to join in. I had a tradition in graduate school that every Friday was Hawaiian Shirt Friday, and Dr. Belk is maintaining that tradition right now as we speak on this Friday, this beautiful Friday.
Just for you.
Yeah, well, I appreciate that. And I missed out on the opportunity. As soon as he popped up on the screen, I was like, gosh, darn it. I should have remembered that. But now with my day job at the University of Idaho, it is Vandal Friday for me, and so I'm sporting my Vandal attire at the time. But yeah, I really missed out, and I need to jump back onto that bandwagon because that was a lot of fun. So, and it's a very nice shirt you're wearing too, Dr. Belk. So to get into what the topic that I wanted to visit about today is something that it became very apparent to me when I began my PhD work at Colorado State University, and especially one particular class that Dr. Belk used to teach, or maybe still does. It's not issues in animal agriculture. What's the name of that course?
Interpreting animal
Interpreting.
science
There
research.
we go. Interpreting animal science research. Yeah. And it was kind of the first time that I finally start to really put things together. And no offense to my previous advisors and all of the folks who have helped me on my animal science career. But sometimes a thick skull like me takes a few more tries. And so we really started to get into what it is to be a scientist, especially a scientist at a land grant university. And we're going to touch on that here in a little bit. But I thought, who else would be better to talk about the scientific process and the scientific method? We talk about the science of meat on this podcast for all of our processors and academics out there, but sometimes we need to be reminded of that, especially from the academic world, but many may have never really heard the basics of it and the definition of it. And so, Dr. Belk, would you enlighten the listeners a little bit about what is the scientific process and hypothesis-based science?
Well, I think around the world, people that work in the scientific profession have varying definitions for what the scientific process is. The way that we've always taught it is the idea that you would formulate a question that needs to be answered. You would put together an experimental design that would address that specific question. And, experimental designs have to be very detailed and thorough in terms of truly focusing in on that particular question that you're trying to answer. Then you conduct that experiment, and then you evaluate the data that are generated from that experiment in a fashion that's appropriate for the type of data that you collected, and you publish your work. And during that process, of course, you formulate conclusions about what the science says. And I've always taught that, one study doesn't make a fact. It's important that you have several studies that are performed maybe from different vantage points that help the community of scientists that work in a given space to develop consensus on what the facts around a topic actually are. And that's proven successful going back till to medieval times. And I think it's a good philosophy for addressing issues that the industry faces. In my career, we've always focused probably more to the applied side of questions in research than to the basic side. There's really not very many basic scientists in the world today. I know that people say that they're more basic than applied, but at the end of the day, funding follows application today. And so, really, in truth, most scientists have some degree of applied um, knowledge that they're trying to address when they're conducting an experiment. And that should enter into that process of developing an experiment that's answering a specific question. So,
Well, and let's elaborate on that just a little bit, because mentioning basic and applied, and I would agree with you that most folks have an applied focus somewhere in their experimentation, and I'll have you to kind of define those two. But I live very much on the extreme end of the applied spectrum. I am a kill it and weigh it kind of meat scientist. I like to be able to take what I'm doing and just drop it right into a packing house or a processor situation. But let's have you go ahead and define that difference between basic and applied, so the folks out there listening can better understand the vastness of the scientific community.
yeah, that's a good question. And, the way I've always taught it is there's no such thing as applied only and basic only research. It's actually a continuum of degree of application. A true, 100% um, basic study basically has no purpose. It has no foreseeable use in our society. And what's interesting about this is that there's people that say that they're basic scientists, but there's not really only, at least in North America, there's only one source of funding for truly basic research today, and that's through NSF. And that's you're applying for grant funding there where there is no intended or conceivable use for whatever the discovery is that you're making. And you move from there then towards the applied side of the equation. A truly 100% applied study is being conducted specifically to answer a very detailed question about a need for the industry or for the government or some need. And so the results of that study will immediately be used, implemented into whatever the process is that funding resource has funded it for. And they're going to use that information immediately out in the industry or in the regulatory circles or for whatever it was for.
Hmm.
And
Yeah.
then everything in between, various degrees of.
Yeah, well, and you're absolutely right. Where it is that continuum, and where do you fall on that? And for those who are out there less familiar with the term NSF, the National Science Foundation, is going to be, if you're looking at the basic, and you can correct me if I'm wrong, but it's almost like you're setting a table, but you don't know who's coming, and you don't even know what we're going to be serving yet. It's just
Yeah.
it's pure discovery.
It's science for the sake of science.
But often leads more into eventually to the applied, or at least hopefully.
It can,
Yeah.
it could be 100 years from now when
Hmm.
somebody figures out how to use a discovery from the basic side that, in some application. Um, so it certainly could at some point, but
Yeah.
at the time of the conduction of the work, there's no foreseeable use for it. So
Right. Right. That's excellent. And okay, so this kind of leads me into, you've already mentioned it a little bit, but this kind of leads me a little bit into more, once a study has been conducted, we got to get the information out there. And a lot of our processors out there may be getting their information from our periodicals that are shipped to them. We have a variety of magazines in the industry, but that information comes from something. And so once a study is conducted and completed, we need to get that information out there. And so maybe you can share a little bit of the behind the scenes of what happens to get it out.
Yeah, and this, I've always taught graduate students that the easy part is designing and conducting the experiment.
That's right.
The hard part comes later, right?
Yeah. Yep.
So, you really haven't conducted the scientific process unless you first evaluated the results in an appropriate manner. And everybody who's going to watch this has seen examples of data that were evaluated with both appropriate and inappropriate means. And so it's really important. I mean, I've always taught that people that do science should be trained to do science, just like a lawyer is trained to practice law or a medical doctor is trained to diagnose disease. People develop knowledge about how to conduct science correctly, with time and experience and wisdom. And it never comes easy. I mean, it takes effort and work, and I think everybody that watches this could relate to that.
Yeah.
Once that analysis is conducted, though, that gives you the basis for testing hypotheses that allow you to formulate conclusions. And that's really that's the crux of what we're after. When you first set up that question that you wanted to address, you want to get to a point where you can truly answer that question. So you can say, the objective of the experiment was this, and based on conducting this work and evaluating our data, this is what the answer to that question is. And once that's done, you feel like, okay, I'm in the major league now. I have a conclusion. Really, it's not over yet at that point. The scientific process requires transparency, and it requires review of your work by others with expertise in that area, basically to criticize you. So a scientist's job is to subject themselves to criticism. That's what we do.
And it's very painful sometimes, by the way.
Sometimes it's painful, yeah. I remember the first time I published a paper and it came back red.
Yeah,
So,
yeah.
but the idea is you construct this paper which outlines what your question was, how you went about trying to answer that question, which is your materials and methods, what your data resulted in. I mean, what kind of data you collected and what do they look like, and how you analyze them. And then you formulate from that, based on some test of hypothesis, a conclusion. Mm-hmm. And you submit that then in the form of a scientific manuscript to a credible society that publishes scientific results. And they will then take that manuscript and farm it out to a group of peer reviewers who they think have, some facet of expertise in the topic that you're publishing in. And those people will review that paper. And, it could be that you didn't communicate something clearly in that paper, and they'll question it. Or it could be that you've done something wrong statistically that they know more about, and they'll question you on that. And so you have to go back to the drawing board. But that whole process of peer review serves really in the scientific community as quality assurance.
Yeah.
That's how we assure that once something is published, it has credibility that's not only formulated by one principal investigator that conducted the study, but basically the scientific community. There's various levels of rigor, I would say, in the process. I recently saw a paper published where they called it research, and they actually were calling out and criticizing other scientists in the paper. Didn't feel like that was too good of a peer-reviewed study, and would question the credibility of that journal. But I think for the most part, scientists understand this process, and the more rigor you have in the evaluation of your work, the more credible it is then when it's finally published. And so that's the reason those journals like Nature and Science and, some of those higher impact factor rated journals, they have those impact factors is because they are extremely rigorous in terms of their review process. And so you respect that.
Yeah. Yeah.
But the end of this thing is, to get that thing published after that review process in a transparent fashion that that makes the work credible. And today, it's not uncommon. Like we do a lot of metagenomic work here where we're collecting sequence data, huge amounts of memory is taken up by this data. You publish all of that along with the manuscript now, so people could actually access your raw data information to perform their own analyses if they chose to do so. So it's becoming more and more transparent as time goes on.
Yeah. Well, yeah, definitely a rigorous process, and I appreciate you mentioning the transparency of it all. The reality is that anybody should be able to, if they wanted to, uh, gain access at some point to the data to see, can we replicate this in another manner, or can we analyze it in a different way? And so our particular journal at the American Meat Science Association, just to give a shameless plug because I love our organization, is the journal Meat and Muscle Biology. And so for folks out there listening, if you're not within the scientific community but want to kind of see how how research is initially published and goes through that process, you can check out Meat and Muscle Biology and see where some of our colleagues are publishing, and currently I'm actually working on revisions to a manuscript I just sent in. So
I'm just reviewing one actually as we're doing this
is that
interview.
right? Yeah. See, that's part of the society part, and part of being part of the greater scientific community. It's not just conducting data or conducting research and collecting data, but then it's also being part of the review process. I mean, that's just as critical as to help with that feedback so that we all get better.
Yeah, absolutely. Agreed with that 100%. We all have to devote time to that process, or else the process in itself is not functional. So
Exactly. Yeah. And it's really neat how the editors will take will build their listing of folks over the years to make sure that we have the right experts reviewing the right projects. And so if it's about enzyme work, we try to find folks who are experts in enzymes, or meat processing, further processing, value added things. It's great to have the reviewers out there who have that expertise so that we produce a high quality product in the end.
yeah, and you want people to review it sometimes that are further away from what you're doing specifically, because they may notice that you haven't communicated something really very effectively in just a single sentence in a
Yeah.
paper, and they can help you make it better by asking questions about their understanding of it. So
Yeah, yeah. Well, and again, for those who are not in our who are not a day-to-day scientists, there's a lot of review and revision that happens even before it gets to the journal review. I back. I'm holding a red pen right now for those who can't see it, but I have a feeling Dr. Belk has worn out a number of these over the years, especially reviewing my dissertation in the past. And it is quite humbling the first time you turn a project in that you've worked so hard on, but in the end, it needs to be clear in the thoughts that you're trying to present. And if it's not, we're missing out on the objective. I mean, we did all this work, and if you can't share the information appropriately for the vast people to understand, then we're missing the point. And so Dr. Belk really helped me a lot with just writing concisely. We don't need to be wordy, but writing concisely but clearly. It's so important, the clarity.
we used to focus on trying to construct sentences that can only mean one thing.
Yeah.
So if you read a book of fiction, you'll read sentences where they're trying to flower them up, and rightfully so. I mean, that's sort of art, right?
It's art, yes.
And but if you had 100 people read a sentence, you might get 50 different interpretations of what that sentence was intended to mean.
Mhm.
And and that's not a good thing in science. In science, you want people to understand a sentence to mean exactly what you wanted it to mean. And if they don't, we got to fix it.
That's right.
And that's part of that review process. And for your relative to your comments, we all learned how to do this.
Yeah.
It's not something that you were born with innately. And so, I had people that taught me to write, like a J. Darrell Tatum and Gary Smith and Russell Cross and Jeff Saville. People that taught me how to write. I'd get my work back and it'd be read just like yours was. And the key to becoming successful as an author is to review what people have told you. Don't take it defensively.
Right.
Take it constructively and try and figure out, why did they not understand the sentence? What did I do wrong? And redo it. And the more times you do that over long periods of time, the better an author you will become. And I think that's where all of us have been at one point or another. So I guarantee you, I was not born with the ability to construct sentences. So we all had to learn it.
Well, and I'm grateful for all those who had coached you over the years as well, and it's really helped me. I know every time I'm working on a paper, or even down to an email, I may rewrite a sentence over and over just to make sure that the point is clear and getting across, right? So
Scientists tend to do that.
yeah, yeah. Then of course we have to make sure that it's not a paralyzing. Of course, like eventually we got to move on with life. But yeah, we have a tendency to want to make sure that our points are getting across clearly. So, Dr. Belk, you are employed at a land grant university, Colorado State University, as am I. I'm grateful to have been a part of those organizations. And the term is used an awful lot out there, but I have a feeling awful lot of folks don't know what that is. And so, would you mind telling the group a little bit about the background of the land grant institution, and then kind of how that has led to science as it is today?
Yeah, sure. So there's several levels of land grant. The original land grant system was put into place by the Morrill Act in the 1860s under Abraham Lincoln. President Lincoln wanted a system in place where in each state in the Union at that time, you had people that were able to help, really, farmers and ranchers and engineers improve on their capabilities from a technological perspective. And so that's where the concept started. Of course, it's ballooned to something much broader than that today. But so the federal government essentially ended up, through that act, through the Morrill Act, giving each state back some of the federally owned land that it had acquired, and allowed the state then to use that land to put a university on that could sort of serve as this interface between producers in that state and the academic system. And so land grant university is kind of unique because it really has three missions. It's supposed to teach students. So all universities have an education program to teach students, but it's also supposed to conduct applied research, and it's supposed to have an extension system, which is really unique to the United States,
Mm-hmm. Yeah.
where you take the results of the research that's being conducted and you get it implemented out in the industry. And that's the purpose of the extension program. And so over time, of course, as I said, that mission has broadened. And so we do a lot more things now at a land grant university. But all the original land grant universities in each state originated with that purpose. And then now there's 1870 land grants. There's other layers of land grants that also perform a similar mission to a more diverse audience. But I think it's something that we should be proud of in the United States. It's quite frequently taken for granted. I've hosted a lot of people from a lot of different countries that have come here to visit and evaluate our science programs or learn how to implement new technologies in their own countries. And they've always all been impressed with and appreciative of the system that was in place, not only to do the work collaboratively with industries and governments and whatever, but then to extend that work out so that it's implemented. That's an important concept that you really don't see in other countries. And so that's the principles of the land grant university.
Yeah.
Today, we also take it upon ourselves to try and make education more available and affordable for youth in our states. And all of those things, in terms of mission, have become hugely important to that system. So, I mean, I could talk about this for a long time, Phil, but it's really, really an important system that we very frequently take for granted in the United States. So,
Yeah. I'm grateful to be the very first instructor that most freshmen in our animal science program encounter, because I get to share a little bit about what the land grant institution is, and I'm very, very proud of its agricultural roots. The point being is that it was meant to help this country produce food. Um, in a fiscally and responsibly and sustainable manner that can feed our masses, and as a result, we are one of the superpowers of food production in the world. But it's such a beautiful system too, with that tripartite mission of teaching, research to help broaden and expand upon the knowledge that we already have, and then the extension service, which is for those who are maybe professionals out there or anybody who has ever been part of the 4-H program. That's extension. That is a line item in the extension budget. You are being serviced by the land grant institution mission. So,
yeah, I agree. And as I say, it's easily something that we take for granted. And so
yeah.
sometimes it's underfunded. But, uh, but
Yeah.
it's interesting you say that, because if you go back in the history of the land grant system and look at the universities that essentially were created under that system, at one point or another, most of them, not all of them, but most of them have the name A&M
Yep.
as the part of their the title of that university. So just like Texas A&M,
Mhm.
as that A&M stands for Agriculture and Mechanical School. Colorado State University at one time was Colorado A&M.
Yeah.
And so they've changed as they've morphed and as they've expanded and broadened their objectives. But that was the roots of the land grant school. So
Yeah. Yeah. And I love that. And we need to remind folks of that, that we are based in agriculture, and if you're not involved in agriculture or mining, you're not involved in anything, because that's what that's what does the whole that's what produces everything, and so um uh I appreciate all of that, and that's kind of the end of my questions, but I do want to make sure that we touch on one last question that we ask all of our attendees, our interviewees, is how did you get involved in meat science? I think you have a pretty cool story to tell.
yeah, I don't know if it's a cool story or not. So when I was, I grew up on a small farm and ranch, and we had cattle and sheep, and we fed some cattle. And um, at when I was in high school, things were much different because I'm getting a little bit long in the tooth. But there was really only one place I was going to go. I was going to go, and I ended up doing my undergraduate degree here at Colorado State University. And it was much different then. It was much smaller. Um, Probably there were a lot fewer students because the students that were coming into the university were entering sort of that land grant concept,
Hmm.
which, as I said, has now broadened. But I came here and I wanted to livestock judge, and like most students, even today, I thought I was going to become a veterinarian,
Yeah.
and I'm sure that's pretty common
Yeah.
characteristic. But what happened is I made pretty good grades, but as I got into a fraternity house that was a professional agriculture fraternity. And there was a whole bunch of us that I'd grown up with and that I knew, from my time judging in high school. And we decided to all go out for the meats judging team. And so we did that. and we ended up having a pretty large team. But I judged and started out in 1979 and judged in 1980 and 81. And interestingly enough, most of the people on that team are still my friends, close friends
Yeah.
today. But uh, but that changed my entire view of the industry because prior to that, I knew live animals, I knew livestock, and I still do, and I still appreciated what we did. My kids grew up with livestock and everything else, but the meat side of the industry was a completely new thing at that point. I'd never been exposed to it, and it turned out I really liked it.
Yeah.
And so the time came. So the way it worked here is you judged on a wool team, then you judged on a meats team, and then ultimately you tried to finish up judging on the livestock team. And the reason for that is because livestock judging is not very objective. There's a lot of
Yeah.
subjectivity. And so um, I guess they try to hone your objectivity skills with it. But at any rate, I got to the point where I started out my livestock judging. I was in the fall semester of that. Dave Daly was actually my coach, who's well from,
Wow. No kidding. Okay.
and I was offered the opportunity to go to graduate school,
Okay.
and they said, here's the opportunity to go to graduate school. We'll give you an assistantship, and but to do that, you got to coach the meats judging program,
Right.
and so I weighed, the opportunity to livestock judge versus the chance to go to graduate school. And I thought the return on investment might be better if I went to graduate school. So that's the path I chose. And I ended up coaching two meats teams here. I started out while I was an undergrad. As that process was occurring, I did some internships with Safeway stores in their meat division, which was much different than it is now
Mhm.
in these days. But it was a great opportunity to learn how the real meat industry works. I hugely encourage that for students today if they think they'll have any interest in being in the meat industry, and I never looked back.
Yeah.
So yeah,
Yeah. Well, and you've been involved in the academic world, obviously, but you worked for USDA at one point. Is that right?
yeah,
And then also have had the time in the commercial industry as well.
yeah. When I finished my PhD degree, I left Safeway. I went back to school to finish my PhD degree. I was heavily encouraged to do so by a guy named Gary Smith.
Yeah.
And so I did that, and I worked with Cross and Sable at Texas A&M. When I finished, there was a lot of meat scientists and not too many meat science jobs.
Right.
And so a position opened because of a GAO criticism at USDA to start a new program related to, exporting more value-added products outside of from the United States to other countries. And
Mhm.
so AMS applied for that. The Livestock and Seed Division is what it was called at that time. They applied for a position to address these criticisms, and I was the first guy they hired. And it was a unique federal job, and I've learned to not take it what the opportunity was for granted because, um, you know, most federal jobs are very, I would say, precise in what they want you to do and what you're allowed and not allowed to do.
Yeah.
But the guy that hired me was Paul Fuller and Barry Carpenter, and at USDA, and they said, "Here's some money. We don't know what to do, so go do something." So that's how I got started. And
Well,
then when the job opened at Colorado State, it was about 3 or 4 years down the road, and I had the chance. Came back here. I came back here, but
well, and with your international experience, then I mean that has helped to really foster a career that has been worldwide, world known, and then and you have traveled to all of the countries as far as I'm concerned.
I kind of lost count. But
Yeah,
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 I've been a lot of places, and that's been a blessing, and
yeah,
I've been fortunate to do that.
yeah. It's pretty amazing. Yeah, really opens one's eyes, and I will concur with you on the fact that the back to the land grant mission is that we are very unique that we have that, and an envy of many other countries for folks who live there but realize what they are missing, and so it's a pretty cool thing to be a part of. So.
Agreed.
Yep. Yep. Well, Dr. Belk, I'll let you get back to your busy day. Make sure you get that paper reviewed so that some wanting author out there receives their feedback. Um,
Dr. Gilger will be on my case if I don't get it done.
That's right. Yeah. Dr. Dilger is one of our lead editors at the Meat and Muscle Biology Journal. And so, yeah, folks, get out there, get to know um, the scientific community if you're not part of it directly. And if you are, this is always very enlightening to just go back to the basics and understand why we do what we do and how we do what we do. And so, Dr. Belk, thank you so much.
Thank you. Appreciate it.